Hello, my name is Lukas Rosenstock and I'm the co-author of the book Designing APIs with OpenAPI and Swagger. I'm excited to be speaking at Manning's API conference, and I will talk to you about From Domain Model to API, an approach to API design first. Hello everyone, and welcome to my talk From Domain Model to API, an approach to API design first. My name is Lukas Rosenstock, and I am a freelance software developer, technical writer, and API consultant. Also, I'm co-author of the book Designing APIs with Swagger and OpenAPI, which I'm writing together with Josh Ponelat. This book is currently in Manning's Early Access program and will be available in full very soon. So, let's get started and talk about API design first. So, if we have an API, we want to have an API definition that describes how this API works. And ideally, this API definition is also machine-readable. And the standard for machine-readable API definitions is OpenAPI. Now, there's one way to use OpenAPI, and that is to have an existing API, take your implementation, and then either through auto-generation or manually document that implementation as your API definition. And then you can use that OpenAPI definition and you can generate reference documentation using a tool like Swagger UI. However, what if we turn that process around and instead of starting with code and later create a definition, we started with API design. And then from our API design, we create an API definition. And the advantage of going API design first is that we can not only generate the reference documentation, and we can now do it even before the API exists, we can also use the API definition to generate some code automatically. For example, client SDKs, for example, server stubs, or we can create a full mock server based on the API definition, and we can use that for testing, so we can test whether the code matches the specification, the API definition. So, in this way, the API definition becomes the single source of truth, because the API definition comes first and then it drives all the other artifacts and the whole API lifecycle. Now, if we want to go API design first, maybe the first question that we should look at is, how do we design an API? To use a practical example, we will start with a web application called PetSitter. And that's the example which is taken from our book. And I'm basically presenting you the gist of 2 chapters of our book where we describe this process of starting a project, going API design first. So, let me introduce you to one of the protagonists of our book. It's Jose, and he's a dog owner and a big fan of dogs, but because he's busy with his business, he sometimes needs some help, and he needs to hire someone to take his dog for a walk. And to streamline that process, he has this idea of creating a marketplace called PetSitter. He writes down, just like a napkin sketch, his idea for a pet sitter. So he says, on PetSitter, people can sign up and they can either be a dog owner or a dog walker. And then the dog owners, they can post jobs to the marketplace, and the dog walkers, they can apply to these posted jobs. And apart from these functional requirements, he also decides that he wants to use APIs in this project. And more specifically, he wants to build an application with a separate front-end and back-end. And he wants to build with a team of 1 front-end developer and 1 back-end developer. And the approach is he wants to develop the API design first as a team, and then each developer can implement their part separately. And ideally, in the end, everything works together because both work on the same API definition. To create your API design, in the first step, you don't even need OpenAPI, you don't even need a computer. You can also do that on a whiteboard. And what you do is a process called domain modeling. And the idea behind domain modeling is that you create software representations of concepts in the real world. So you look at the domain of your project, and then you identify the concepts or the nouns that you have there. And then you look at what kind of attributes do they have, how do they behave, what can they do, what can be done to them, and what are the relationships between those concepts. And once you've collected all this information and put it together, you have a domain model. And the domain model can be visualized, for example, in a UML diagram, which is what we'll do. This is the file in which we'll show the examples now. So the pet sitter team starts brainstorming and they think, okay, we have an app, so our app has users, so user is one of our concepts. And since it's a marketplace, the job is another concept. And since this whole thing is about dogs, we should also put a dog concept into our domain model. And after identifying these concepts, they add attributes. For example, for the user, you have things like an email address and a password. And for jobs, you have the time when the job starts and what is the exact activity that you should do. And for the dog, you have things like the dog's name, the age, or what kind of breed of dog it is. So we've identified concepts and we've added attributes, and now we have to look at behavior and relationships. And to do that, it's very helpful to write down user stories. And user stories basically describe from the user's perspective how they interact with the software. And by writing down user stories, you can find out, okay, what kind of behavior and relationships do we need? And I will not discuss the user stories right now because we have limited time in this talk, and I want to focus on the aspect of going from domain model to API design. So I will just present you the final domain model where we have the user, job, and dog concepts. And while writing user stories, the team realized, okay, because people apply to jobs, we should have a job application concept. And all these concepts now have attributes and they have actions and there are relationships between them. Now, the next step is how do we get from this domain model, which we've visualized in UML, to an API design and then to an API definition. And actually, these aren't two separate steps. We can do this both at once because we can take the domain model and we can directly write down our API design in OpenAPI, and so we have the API definition. But how do we do that? So we can take the concepts that we've identified and their attributes, and we can convert them to JSON schemas. And then we can look at the behavior and the actions, and we can define operations, so path method combinations. And finally, for the relationships, we may have to change the schemas and add information and also into the operations, but we'll get to that in a bit. So let's get started with the first, the JSON schemas. So on the left side, we have the user concept in our domain model, and on the right side, we have the OpenAPI file, which contains a user schema under component schemas. And as you can see, the attributes in the domain model and the properties in OpenAPI, they are the same. The only thing that we did at this point was adding data types. And when we look at relationships, let's take another example. We have a job concept. So sometimes we have to add some properties because we want to represent a relationship by putting its ID, the ID of the reference resource, as a property. And sometimes we want to make a direct schema reference because we want to include one schema into another. Okay, so we've got schemas, but how do we design now a CRUD RESTful API? And a lot of people, when they talk about RESTful APIs, they actually mean this CRUD. So CRUD, which comes from the field of database management systems, stands for create, read, update, delete. And that's the basic operations which you can do on data. And looking at them in the context of an API, with a CRUD API, we generally have two types of endpoints. So we have collection endpoints for all the schemas that we have. For example, if we have a user schema, we have the pluralized noun users, and we have an endpoint at /users. That's a collection endpoint. And we have resource endpoints where we take the collection endpoint and we add / and the identifier of one specific instance of that schema. And yeah, that's the two basic endpoints that we should have in our API design. And then we can take these four operations, create, read, update, delete, and we can map them to HTTP methods. So we can use post for creating, and we typically use the collection endpoint for that because we're adding something to the collection. We can read, and we can read the collection endpoint where we get a list of items, and we can access an individual resource. And if we want to change or delete a resource, we can use the put, patch, and delete verbs on the resource endpoint. So let's take an example. Look at the user concept. So I'm skipping the login action here because it doesn't directly map to these CRUD things, and we don't necessarily need it here because we'll take care of authentication in a different way. So let's just skip this and look at the four other actions. And what you can see here is that there's a very good mapping between the actions and the CRUD verbs. For example, register. When we register, a user gets created. So register is actually our create action, and so we have post /users. And we have view, modify, and delete, and those map to read, update, and delete, and we use the resource endpoint for this. So this is pretty straightforward. And when we look at the job, this time I'm skipping create, modify, and delete because again, it's the same thing. But what I'm showing you here is that we have three different actions, and they are all read in CRUD. So but they map to different endpoints. So we have list all, that's the collection endpoint. We have a view for a specific job, that's the resource endpoint. And we have list my own. And here we actually take that action and we generalize it a bit and say, okay, listing my own jobs, that's a specific case of listing jobs for a particular user. And we can add something else to our API design, which is called a sub-resource collection endpoint, where after one schema type, so users, and the resource endpoint for a specific user, we add another schema for a related. We add another related schema. Yes. And the next question is, okay, so we have these operations, but what should be the input and output, the request and the response for these? And here we can reuse the schemas that we created before, and very often we don't have to do much else. For example, for create job, we can use the job schema, which we reference here from the component section, as our request body. And this is the action list jobs for users. And as you can see here, we have a response body where we have a schema, and that schema has an items array, and inside that items array, again, we reference the same job schema, so we can reuse our schemas everywhere in the API, and the API remains consistent. Sometimes we have to think a little bit out of the box though. So creating a job application, that's again straightforward. But what does it mean to approve a job application? But yet again, we can very often for these actions map them to the CRUD paradigm by saying, okay, what does approve mean? Approving a job application means changing its status from, let's say, applying to approve. And by that logic, we have created or we have mapped the approve action to an update verb, and we can use it in our same consistent CRUD approach. So let me summarize. So when we want to go from domain model to API, we can generally convert all our domain model concepts into JSON schemas in our OpenAPI file. And these are reusable in different areas of the API for requests, for responses, for being referenced in other schemas. We can generally, to have a consistent architecture, we can use resource and collection endpoints as our operation paths. We may not need to add all of them, but for the schemas where we have actions that need them, we can add those paths. And then by having the CRUD actions, create, read, update, delete, which roughly map to HTTP verbs, we can look at all the actions in our concepts and try to interpret it as one of these, and based on that, add it to our API design. And that's all from my side. Thank you, and let's stay in touch. If you want to talk more about API design, you can reach out or follow me on Twitter. My handle is @Lukas Rosenstock.